Following trends and like the latest hot framework that's out there is really cool. I like playing around with a lot of tools as well. But you might have a sneaking suspicion that all of this stuff is the same. You're right, because they're based on research papers. So there's a lot of research that's come about in the last year and a half. And a lot of the tools now that we're seeing and a lot of the frameworks and libraries are basically taking some of those papers and implementing them verbatim. So today we're going to start with a couple of core research papers that you should be considering if you are into building AI agents. The first one's going to be the self-refined paper. And this goes deep into a topic that is almost intuitive, but I think it's still a good read because it explains how this works at a more granular level. So self-reflection is important because it actually allows the models to improve over time. This process is fairly straightforward. There is some input, and the model then gets a chance to take in feedback and then refine, then take that same output and do the same thing and over again. As this happens, you'll get a better output. So without needing to really work through a complicated process of setting up a multiple agents, just adding this reflect on your own output step can significantly improve the actual output of the model. So there's a bunch of complicated mathematics around this, but the core idea is still pretty simple. The next paper was really cool when it came out, the Gorilla paper. And this one worked with a large language model and was able to connect to a bunch of APIs. And the issue that they were solving was this hallucination problem, where a large language model, if you try to call out to an API it doesn't know about, or maybe it hasn't been trained on extensively, it'll hallucinate some of the parameters. And when you're coding or doing any coding tasks, like a comma is enough to throw off the whole thing. So those parameters need to be explicitly correct. And what they were able to do was figure out how to work with TorchHub, PyTorch, and get the model that they put out to work with these parameters within the code. Now, the model was also able to go out and find a model based on the user's description, like it says here. Help me find an API to convert spoken language into recorded audio text using TorchHub. And so it would go actually find the exact library that needs to be used, use it to complete the task. If you've done any type of low-level development in AI and ML, finding libraries is a task within itself. Trying to go out and figure out which libraries work and then test them. So this could significantly cut down that process. And another piece of this is they were able to create like a good workflow and prove this out for future releases of models that are going to be not only trained on TorchHub here, but it could be trained on anyone's API database per se. So this API database, it was like a little bit of a RAG flow that they have here where the information retriever would help with getting that information from the API database, like its schema, the parameter calls. And then in one shot, they could have the Gorilla model be able to output this type of image here just by the user asking. So the user themselves doesn't need to know downstream what model's being used, what the parameters are, what's the API calls, but the LLM itself would just handle everything. So this is pretty powerful. I can see how this gets connected to agents because at some point agents will just need to go out there and scour the internet, find the right APIs, and the programmer, engineer, marketer, whoever's using them won't really need to know the low level details, but the agent will be able to just on its own, zero shot, figure that stuff out. So the next paper here is Tree of Thought. What I really liked about Tree of Thought was the idea that some of those models weren't good at long range problem solving. So things that required multiple steps of reasoning, it would get lost or muddled with it. So Tree of Thought helped provide like a framework for going through those type of solutions. And it was really good at like math puzzles, creative writing, crossword puzzles. So problems that really required multiple steps and long-term reasoning. That's where Tree of Thought was able to help with. And there were some significant improvements in how models effectively worked overall. And I think this paper influenced a lot of work downstream ever since it came out way back in 2023. Saying that sounds funny, but a year in AI is a very long time. All right, next paper is going to be AutoGen. So AutoGen is a library that is uh, developed by Microsoft that implements the AI agent idea in Python. Although I don't use AutoGen, I still think the paper is really good because this was the first paper that took it outside of just the math and the theory, but it really implemented it, and they provided a library for it as well that people could actually touch and feel. And it gained a lot of traction. I think it's still used a lot today, but one of the other libraries in the space is Crew AI, and LangChain has agents. So agents are just a lot more popular today. So AutoGen is not the only library available. The idea was you would have these agent constructs, and the agents themselves could be customized. And using conversations between the agents would allow you to solve problems that were either too complex or required a lot more reasoning, and that a single LLM wouldn't be really good at. So these are things like making a plan or traveling a path. So the collaboration between the agents was what actually allowed for better problem solving at the end of the day and reaching some goals. Also, there are two types of chat. So there's the everyone talking to everyone type of chat, and then there's the hierarchical chat. And the hierarchical chat is probably more aligned to like parallel data processing. And I think that's one of the more powerful things it really unleashed for folks when they were using AutoGen. It made it a lot more accessible to use agents through a simple library, and also working with a language that a lot of people know, which is Python. And here you'll see that the agents were actually able to write code and do the whole back and forth, that chat component. It's simple on its interface. It's actually really hard to get right. When you're coding something, you need to pass messages back and forth. So it was really helpful in doing that under the hood for you. All right, next up is one of my personal favorites. I think this completely flew under the radar. Not a lot of people actually know about this paper, at least in the circles I read around like AI agents and stuff. It's GPU enabled function as a service for machine learning inference. That's a mouthful, but you can think of this as like Lambda, Fargate, and essentially adding a GPU to it. So instead of trying to provision a bunch of GPUs all at once, you just call a GPU when you need it. This type of function as a service really helps with people who don't have a cluster of thousands of 8100s to run their workloads. Instead, you want to just call that compute when you need it, and you use regular commodity CPU compute when you don't. One of the services where this is implemented really well is Modal, and that is a great service. I use it for a lot of like background tasks. It essentially helps with this problem right here, where you don't want to have to upfront provision a GPU. You don't want to log into any console to actually provision the GPU. You just want to write some code and tell it, use this type of GPU. And it's perfect for that because you just have to annotate the code, and this code doesn't change, but now it just runs on a GPU. So there's code that you could write where if you try to run it on commodity hardware like a CPU, it'll just run too slow. It'll be not usable. But once you switch over to a GPU, it works really well. So you can bypass that whole process, the provisioning, the setting up of it, the managing of it, and just use it as a function. So this is pretty early stages for this type of workflow, but it's getting there. I think over time, we're going to get to a place where this is going to end up really working out in the general cloud, like the hyperscalers, but we're not there yet. It's a lot of startups do this right now. Like I mentioned before, Beam is another one. We can think of Replicate, any of those, like you call an API over the wire and it runs a GPU for you and it does whatever inference. That's where this kind of lands. But this is implemented all over the place, yet I haven't seen anyone do it as well as Modal with the annotation piece of it. All right, next up is Toolformer. So this one is one I personally like because it makes sense to me how they explain this. And the idea is that LLMs can teach themselves to use tools. And this is really good because if you think about the current software engineering, you have to hard code a lot of stuff sometimes in terms of how you want things to be called and how you want things to function. But now, as we move into agent land, there's this idea that API calls and searching the web and browsing databases is going to become almost second nature or built in to these type of agents as a core component of your system. And this paper really dives deep into that idea, and it's good as an overview to understand how that would work and why it works essentially for these large language models. So this one's a bit more mathy. I wouldn't even say I understand it all yet. I have to read this multiple times to even start to get this, but it's a good paper to go through just to get a background on how all the tool stuff works. So those are the 6 papers you should read before going into building AI agents. Again, I don't think you don't need to like understand these at the PhD level or anything like that, but it's good reading because when you read the stuff, it'll be like, oh, this is hard. But once you actually go to build things, it's actually much easier to implement in code. You don't have to really deal with a lot of math unless you're innovating at the level of the model. But in most cases, you're just using a model over an API. But yet, it's really good to understand how this stuff works